Okay, hello, welcome back to our course. Right, we have here the chapter 9 is about the linear modeling. All right. In chapter 5 earlier, we have seen the linear correlation, or at least the correlation between the patterns, right, between the pair of data. Here goes more detail, right? The correlation and regression talk about analyzing paired data. When correlation exists, the values of one variable is somehow associated with the values of the other variable. You can see what they are called right in the next slide. If the correlation between the two variables is linear, then we call that it's linear correlated, or the pair data has linear correlation. So the pair data result in pattern that can be approximated by a straight line. Right? So if we have a linear correlation, we can model a straight line. Right? So for that straight line, we can identify an equation, right? We can identify an equation of the straight line that best fits the data, called the best fit line. All right, so we'll see what that means. Right, the best fit line is given a collection of paired data are linear correlated. The regression line, or the best fit line, or the least squared line, right? Same thing, referring to same thing. And the least square line show the method. Right? It's the straight line that best fits the scatter plot of the data. Right? Best fits the scatter plot of the data. So we have a scatter plot in green over here that shows the paired data set. And over here in blue is just the line going through that describes or modeling the pattern in the best way. Right? How the way is the best, we can see, right? When we define the expected y value to be mx plus b, where x is the independent variable and the y is the dependent variable. Independent variable means x is varying itself, right? And the value it can take that, which makes sense, of course. Well, when x is fixed, then going through the line, we're able to see the expected y value, what that will be. Of course, we'll be a little off with the points over there, right? But that line is best to explain the pattern of the point. So that will be expected of the y value. In this equation, m is the coefficient of x, so that is the slope, and the b is the y-intercept. Where the slope tells is for every unit change of x, the y will be expected to either increase or decrease, depends on the m, right? Expect to change of certain m values, right? So instance here, let me join purple. Oh, we have 8 here, right? So every unit it change, right? 1 unit, that's middle of 8 and 9, right? I mean, that's middle of 8 and 10, so here is 9. And we have the m unit of the y value expect to change. So that is the slope. Right? And the b is the y-intercept, which the line intercepts with the y-axis. So what we do with how we get it, the m and the b, is set m and the b to be unknown. And in this question, the y is the y values of the point. The x are the x value of the points. So we have only m and the b are unknowns. And what we do is minimize the square of the residual, minimizing the sum of the square of the residual. The difference between the data point and expected value is called residual. So we're saying red, the vertical difference, between the point and the line is the residual, right? It has positive value, has negative value, means some point is above the line, some point is below the line. But when we square it, everything will be positive. And we're trying to add them together and minimize this sum to get the m and the b, right? That's one way we can find the m and the b as unknown, right? So it will be as the expression of x and y. So when we find the m and the b, we get the formula. M is some square error of the product over some square error of the x. B is y bar minus mx bar. Right here, m is the previous m here. Y bar is sum of y over n. X bar is the total of x divided by n. Right in here, n is the total number of pairs. The sum square error of the product and x, they are expressing as this long formula here. Well, that is just a list out. You don't have to find or calculate it actually, right? So for this number, it looks tricky enough. Too much work, right? So what I do is I'll provide you those numbers. So you just need to plug in to your formula of m, and then use m and x bar y bar to find b. Right, finally, if you need to draw the line, the points are what we are using is 0, b, and x bar y bar. So it's better to get x bar y bar done in the beginning. Right? So let's see example how to do this question. Right, so we have a pair. Right, draw the best fit line. We have pair where x is 1, y is 15, x is 2, y is 14, x is 2, y is 11, x is 3, y is 9. And the last pair, the fifth pair, is 4, 7. Right, so apparently n is 5, and the sum of x and the sum of y is provided. Right, the row totals, in other words, are provided. All right, so what the question wants us to do? Draw the scatter plot with the line, and what does the m do with the y? Right, so what? So we need to draw the scatter plot first, right? That will be the easiest thing to do. 1, 2, 3, 4. Right? Gap of 4 to have 1 for the x values, since we just have 4 of the x, right? Since x just go from 1 to 4. And the y value is go up to 15, so look like we have enough space when we have a gap of 1, right? Each box to be 1, so we just mark or label just every 5 units. And it's like a decreasing pattern, so maybe the y-intercept will be going up, will be higher than the largest y value, right? That's the idea. Okay, so scatter plot. Let's have it in blue, right? Where x is 1, y is 15. Right, that's this point. Where x is 2, y is 14. That's our second point. Also, third point is also having x to be value of 2, but y is 11. The fourth point, x is 3, y is 9. And the last point, where x is 4, y is 7. Okay, so we have those 5 points as the scatter plot. As the scatter plot. So now we need to find the equation, right? The equation we have what? We have x bar, y bar, we have m to find, we have b to find, right? So first of all, we do x bar and y bar, right? X bar is sum of x over n. That is 12 over 5, right? And you can use calculator. 12 over 5 is 2.4. Right? Then y bar is sum of y over n. The total, row total is provided 56. Divided by n is 5, right? N is number of pairs we have. We have 5 set of xy, right? 5 pairs of xy. And we have 11.2 of the y bar, right? Of the quotient here. Then what? Then slope and y-intercept, right? The slope will be some square error of the product xy divided by some square error of the x. That's negative 14.4 divided by 5.2. Right here, we need to graph it, so 1-digit decimal will be good. Negative 2.8. And the b will be y bar minus m x bar. That is what? 11.2 minus negative 2.8 multiplied by 2.4, right? So what we have? We have 11.2 minus, we need a parenthesis, right, for another negative, times 2.4. That's 17.92 or 17.9. Right, so we have the best fit line is negative 2.8x plus 17.2. That's our equation, right? Pass through the points 0, 17.2, and 2.4, 11.2. Right, they are 2 points. It passed. Right, so let me write in drawing some other color. Maybe this color. So we have what? We have 2.4, 11.2. 2.4 is a little bit less than 2.5, right? Somewhere here. 11.2 will be somewhere bigger than 11 a little bit, right? So it could be this point, right? And we label it 2.4, 11.2. And another point is the y-intercept, 0, 17.2. Right, so 0 goes to 17.2, a little bit bigger than 17. Right, so label it 0, 17.2. Okay, then what we have is just connect them, right? Connect them by straight line and extend it, right? So that's our line, right? That's our line. What the slope means, right? For every unit increase of x value, we are expect to get y value in this case, the slope is negative 2.8, right? So it's decreased. To get y value decreased by 2.8 units. Right, so that's what we expect for the slope. Right? Every 1 unit of x increase, the y is expect to get 2.8 units decrease. I expect to get y value decreased by 2.8 units. So that's what the slope shows us. Okay, so that's the full calculation of this thing, x bar, y bar first, the slope, and then the y-intercept. After that, we use the slope and y-intercepts to write out the equation of y hat, right? Y hat. Then the slope means every unit of x increase, we expect to get y value decrease by this thing. And if you need to draw the line, you list out the point they pass through, right? If you don't need to draw, then you don't have to mention it. So I'll write it a little better in a better way. Okay. All right. Then the next question will be similar, right? The next question will be very similar. Right, about the tip, right? It's a similar idea, same idea, but what? But look a little different, right? Student, let's read the question. The table, student waits on table at a restaurant, record the cost of meals and the tip left by single dinner. Right, so we have the cost of the meal of the dinner and the tips left. Right, you get $4.75 for the cost, left 50 cents. Got $20.42 for the cost, and the tip left was $3. Right, so that's this relationship. Find the equation of the best fit line. That's first thing we need to do. What does the slope means? Have to do with the tip. How? Right, that's the second one. And then if the next dinner, right, we want to interpreting our result, right, make an interpretation. Right? If the meal cost next will be $10.50, how much tip would the waiter expect to receive? Right, so 3 things asked. Then, but basically everything is based on the best fit line, right? So best fit line, we find out the x bar, y bar, that's the basic. Total of x, that's $53.50. And how many pairs total? 5 of them, right? So use calculator to find 53.5 divided by 5. That's 10.7. Y bar, that's sum of y over n. We get what? Sum of y is 6.9. 5 meals. 1.38. Right, so that's the y bar. X bar, y bar, then we have to find the slope, right? The slope will be some square error of the product over some square error of the x. The little s looks a little weird. All right, still weird, but okay. That's 23.711. That's the sum square of the product over the sum square of x. That's 151.0858. 23.711 divided by 151.0858. Right, we get 0.1569. So here we don't need to do anything about graphing. So as many digits we could, that's good. Right, if you want to keep 3 digits, that's also fine, right? 4 digits, that's okay, right? 157. And the y-intercept is y bar minus slope times x bar. Y bar is $1.38 minus slope is 0.157 times 10.7. 1.38 minus 0.157 times 10.7. Right, that's negative 0.2999. Okay, so from that, we get the equation y hat equals 0.157x minus 0.2999, right? Just use whatever you have. If you kept 4 digits, then you have here 4 digits, then maybe you get some other number, right? So that's the first question, right? What is the M? Second question, what is the best fit line? Right? Second question, what is the M means in this question, right? So that means for every $1 increase in meal costs, the waiter is expected to get more tips. Right? Here is 0.157 in dollar. You could put 16 cents, right? But here we have 0.157, so whatever, just put it. That amount more tips is the waiter expected to get. Right, so finally, when we plug in the $10.50 for the tip, right? So finally, for the tips, when the expected value, when X is $10.50, that will be just plug in the equation, right? Multiply by $10.50 minus 0.2999, 0.157 times 10.5 minus 0.2999. That is 1.3486, so round it to 1.35, since it's amount of dollar, right? Like what we have in chapter 4. 1.3834, sorry. 3486, round it to $1.35. Right, so the tips, the way they expect to get or to receive is $1.35 for the meal that cost $10.50. All right, so that's this question. All right, we have the best fit line, we have the meaning of the slope, and then we have the expected tips, right? Expected tips. Well, use your own wording. So I will expect everyone's wording will be a little different than others, right? So not exact the same wording. Okay, let's see the next question, right? The shoe size. Well, the table below shows the height and the shoe size of randomly selected men, right? For different gender, that data will be different. So it's actually a different gender, it actually matters, right? So here only given a table for men. What do we need to do? Find the equation of best fit line. What does the slope m has to do with the shoe size? And if the man has a here height of 71 inches, what would be his predicted shoe size, right? So we need to predict the value. And over here, provide you the sum square error of the product, sum square error of the x, right? Both of them provided. The x column, the y column, total of x and y. Right? And we have 6 pairs, right? 6 pairs. So still x bar, sum of x over n, that's 429.5 divided by 6. Right, 429.5 divided by 6. 71.5833. All right, draw a little better. 71.5833, right? 4 digits. And the y bar is the sum of y over n. The sum of y is 62 divided by 6. We get 10.3333. Right, keep the more digits, the better. So just 4 digits is good enough. Right, then the slope we have is some square error of the product divided by some square error of the x. Product we find is 46.833. X we get is 111.28. So 46.833 divided by 111.28. That's 0.4211. Right, B is the y-intercept. That's y bar minus slope times x bar. 10.3333 minus 0.4211 times 71.5833. And that's negative 19.8104. Right, so when we keep the final answer for M, we could round it. And for the final answer of B, we could round it 19.81. Right, to 2 digits will be fair enough, right? We don't have to keep everything. Like in the middle, we could, at the end, maybe less digits. Right, so we get the equation y hat equals mx plus b, right? And here b is negative sign, so just attach it, 19.81. Right, so that data is for adults, so the negative or whatever, it's fine, right? Then the slope. The slope is 0.42, right? And we have the unit of height is inches, and the shoe size is just the size, right? Not showing. So for average increased of a man, the shoe size of him is expected to increase by 0.42, right? 0.42, that's what it means, right? Then the last one is want us to predict the shoe size of a man with height 71 inches. So I had when the person is 71 inches height, so we could put a parenthesis, that's where to plug in the x, right? So 0.42 multiplied by 71 and minus 19.81. So 0.42 multiplied by 71 minus 19.81. So you get 10.01. All right, so when you round it, you can just go to 10, right? So size 10 will be the predicted shoe size for the man have 71 inches height. Right, so that is this question, right? That is this question. And that for more example exercise, you can get that on your homework, right? You can get those on your homework. Will be similar question as what we see here. Okay, so thank you. Enjoy your semester and your life, right? Bye.